Let's jump right into this explainer and look at the big picture of wind energy. It's an absolutely amazing topic because wind is somehow one of humanity's oldest tools, and yet it's also one of the fastest growing, most modern industries in America today. We're going to look at how we actually capture the wind, the incredible machines that do it, and the hands-on jobs being created right now to keep those machines running. The contrast here is just fascinating. We've been using sails to move boats across the water for at least 8,000 years, but using the wind to make electricity? That's a much newer idea. Back in the 1880s, a Scottish inventor named James Blythe built a windmill with cloth sails in his garden just to power the electric lights in his cottage. He even offered his extra electricity to light the main street of his town. But his neighbors actually turned him down. They thought the glowing electric lights were the work of the devil. Today, of course, wind power is everywhere, providing roughly 10% of all electricity in the United States.
So the crucial point to remember here is that a wind turbine isn't magic. It isn't some incomprehensible mystery. If you've ever worked on a mechanical motor or taken apart a household appliance to see how it works, you already know the basic principles. A wind turbine is essentially just a giant fan running in reverse. You know how a regular fan plugs into the wall, uses electricity, and spins to create wind? Well, a turbine does the exact opposite. It uses the wind to spin its blades, and that spinning motion turns a generator to make electricity.
To really understand these machines, we need to learn a few key parts, starting with the big box at the very top of the tower. This is called the nacelle. Say it slowly with me, nacelle. The nacelle is basically a heavy-duty protective hood. Think of it like the metal hood over a pickup truck's engine that protects the belts and transmission from rain and dirt. The nacelle does the exact same thing, protecting the turbine's generator, gears, and brakes way up in the sky. Next, we have a brilliantly simple mechanical system called the yaw. That's pronounced yaw. Wind doesn't always blow from the same direction, right? So the turbine needs to be able to turn its head to catch the breeze. The yaw system is a heavy mechanical gear that physically rotates the entire nacelle at the top of the tower. It works exactly like turning a steering wheel in a car, ensuring the turbine's blades are always pointed perfectly, directly into the wind to capture maximum power. But how does the machine actually know when it's time to yaw? Well, it relies on a piece of equipment called an anemometer. Let's sound that out. An-a-mom-utter. An anemometer is a small, spinning weather sensor sitting right on the roof of the nacelle. It completely acts as the eyes and ears of the machine, constantly measuring how fast the wind is blowing and from what direction. It feeds that information straight to the internal computers so the yaw system can adjust. Now, most turbines you see on the side of the highway look like giant pinwheels spinning on a horizontal axis. But engineers have also designed vertical axis turbines that look radically different. They prove there is definitely more than one way to capture the wind, and they come in shapes you might actually recognize from your own kitchen or garage. One vertical type is the Darius turbine, that's Darius. Invented back in the 1920s, it has long, curved blades attached to the top and bottom of a central pole. Honestly, it looks exactly like a massive egg beater. Because the blades are shaped a lot like airplane wings, it generates power using aerodynamic lift, which makes it highly efficient once it gets spinning. Another variation is the Savonius turbine. Pronounce it with me, Sav-von-Us. Instead of airplane wings, this one looks much more like a 55-gallon steel barrel that's been split in half and offset. It works by catching the wind like a simple sail, just dragging it along. It moves a bit slower than the egg beater style, but it offers a simpler, incredibly reliable design that is very easy to build and maintain. But whether you're building an egg beater, a split barrel, or a massive pinwheel, every machine ever built is bound by the Betz limit. That's Betz, named after a physicist. The Betz limit is a strict rule of physics explaining that you simply could not capture 100% of the wind's energy. Think about it. If you captured all of it, the air would completely stop moving behind the blades, and the wind would have nowhere to go. It's a great reminder that just like no car engine is 100% perfectly efficient, no wind turbine can be either. Taking these mechanical concepts into the real world, the industry has grown so incredibly fast that we're no longer just putting these massive machines on open farmland or high ridges. We are actually taking them out to the ocean. While land-based turbines are huge, offshore turbines placed out in the deep ocean are on a completely different level. They can literally be taller than the Statue of Liberty. Why? Because out on the water, the wind is stronger and steadier. And just as importantly, those massive steel parts can be transported on giant cargo ships instead of being restricted by narrow highway lanes, low bridges, and tight corners. And looking ahead, the literal future of the industry is airborne wind energy. These are essentially massive, highly engineered kites tethered to the ground. They generate power high up in the sky where the winds are incredibly fast and consistent. The best part? No heavy steel towers required. All of this incredible machinery, from land to sea to sky, brings us to a massive, memorable number: 50%. This represents the projected job growth rate for wind turbine service technicians over the next decade. To put that into perspective, average job growth in the US is only around 3%. At 50%, the demand for people who know how to safely work on these machines is just exploding. So what does a wind turbine technician actually do? It's a highly hands-on career. If you know your way around hand tools, if you understand how to work with hydraulics, braking systems, and heavy mechanical parts, this field absolutely needs you. It pays over $60,000 a year on average, and what's fantastic is that it does not require a 4-year college degree. It relies entirely on practical, mechanical problem solving and a real willingness to learn. We'll be covering wind power history, turbine mechanics, offshore and airborne systems, aerodynamics, and wind tech careers. Think of this explainer overview we just did as a movie trailer for the rest of this learning module. We just skimmed the surface. Our 5 upcoming audio deep dives will explore these specific topics without giving it all away just yet, and for the ultimate detail, the reading materials provided to you will take you the absolute deepest. So considering the rich history going back thousands of years, the incredible hands-on machinery like the yaw gears and anemometers, and the real-world career opportunities waiting to be built with just a tool belt and some solid training, are you ready to jump into the first audio deep dive? Let's get started.